Yeah. What do you guys? Let's get a bit settled down. So we can start. Sure. Okay, so a couple of days ago, I read this really interesting and crazy definition about testing. So I thought I'll share it with you. So it was written that to tell somebody that they are wrong is called criticism, and to do so officially is called testing. So jokes apart, there's a brilliant analogy from medical science that will help us set the tone for today's discussion. In the field of surgery, the cost of an error while doing a brain surgery is infinitely higher and is very critical, right? If something goes wrong while doing a brain surgery, that person will die. It will be fatal. While the cost of an error while doing a surgery of another organ, maybe it's an orthopedic surgery or a tooth surgery, is not that critical. There might be issues, but it will not be fatal, right? Similarly, if there's a bug, or the cost of a bug, or of introducing structural inflexibility in your infrastructure on which your business runs, is potentially even higher than the cost of a bug in the application code itself. So if there's an error in your infrastructure, or if there's something wrong with that, then potentially all your systems could be rendered unavailable, right? Even your dependent systems could be rendered unavailable. Your system might be compromised. And that is why testing your infrastructure is as important as testing your application code.
Hi, I'm Siddharth, Kulkarni, an application developer with ThoughtWorks for the past 3 months.
Hi, my name is Yahya, Poonawala. Been here in ThoughtWorks for almost 3 years now. Started off as a developer, slowly moving to the ops side, the darker side of the development world, and trying to act as a bridge between the two worlds. The topic of discussion today is how testing your infrastructure is of prime importance and how it plays a pivotal role in delivering high quality products faster, right? So question to you all, what do you understand by infrastructure? When I say the word infrastructure, what comes to your mind? I'm not talking about roads, I'm talking about software.
Servers.
Servers, okay. Networks. What else?
Optimum use of
Complete architecture of the project.
Sorry?
The complete architecture of the project.
Complete architecture of the project. You said something.
What means the optimum use of resources at a peak time.
Okay, so scalability in some sense, right? Auto scaling, stuff like that. Any other thing? Sorry? Environment setups, right? Different environments. Okay, so in summary, infrastructure, I would say, is a collection, based on your answers, a collection of physical and virtual resources, right? Things which would help us support our overall IT environment. As you said, network, storage components, servers, and so on and so forth. There was a trend a few years back, right, where there used to be sysadmins who would provision your machines and developers who would write your application code. And these sysadmins were quite stereotyped. So they would be grumpy old people who would sit in one corner of the office and they would have to manage around 10 projects. Anything you want provisioned on your machine, you'd go back to this fellow. He already had a huge backlog. So he would take his own time. Maybe after 2 to 3 weeks, he would provision your machine, add something, and give it to. I see a smile over there, so I think you'll relate to that. Okay. So that was the trend a few years ago, right? But things are changing right now. There's practically no need of sysadmins right now. The developers themselves can provision their own environments, right? Infrastructure delivery, in some sense, is becoming just like any other software project. And why is this change in mindset? Because the infrastructure is code. The infrastructure is code. So if you have heard about tools, there are some tools called CloudFormation, Terraform, which help you actually provision your machine, like set up your infrastructure. So you can say that, okay, in code, in JSON, I can say that, okay, I want a Linux box. I want the firewalling, so on and so forth. I want this is the memory to be given to it, and so on and so forth. In code, you can say that. Similarly, you might have heard of tools of like Chef, Puppet, Ansible. So these tools help you provision your infrastructure, right? So I can say that, okay, on this box I want Nginx, on this box I want Apache, so on and so forth, right? And as you see, these are backed by programming languages. So Chef is backed by Ruby, Ansible is backed by Python, right? So basically, they are programming languages. And so testing it becomes a critical part of its delivery. You remember, Sid, a couple of weeks back, you had written some really buggy code, which if you would have gone in production, you would have got a resignation letter by now. But thankfully to the QAs in the team, you are safe, right? So testing is sort of a hallmark of your product quality. I'm not saying as Anand had said, I'm not saying about who does the testing, but testing is important. The feature sign-off is required before we move from one environment to the other. And why is this testing only restricted to your application code, right? Why is not your infrastructure? You also need to test that your infrastructure is as stable and easy, and it is possible to host and test your application. So the infrastructure testing comes before your application testing. So as a build-up to what needs to be tested in infrastructure, I'm just going to take a comparison and see how infrastructure as code makes your organization a dud or a hit, right? So a couple of months ago, I had been to this gaming company, and so some stats around that. They were a group of 60-odd people, and they were a 3-year-old startup doing good business, wanted to scale, and had around 60 servers, 2 websites, 60 servers, so on and so forth. And that day they had their deployment, right? So we had gone to observe how they do their deployment and the process around that. Now, what we saw was quite fascinating, and it was a clear sense of something going wrong over there. As we say, the demo jinx, right? That when you're showing it to your client, it bombs. And when they had the deployment, and on that day we landed up, and because of our misfortune, the deployment bombed. Why was this? When we saw the root cause, right? What had happened was that everything was manual. So they had 40 people turning up at 5 a.m. in the morning to do a deployment. And groups of people had been assigned certain tasks. So, okay, these people are going to shut down the server. These people are going to run the script. These people are going to again start the server. They're going to apply configuration. And then they were orchestrated the other 2 people. So everything has to go in an orderly manner. If something goes wrong, one config change here or there, one config missed, and gone, you're boom. So that day when the deployment went wrong, they were down for 9 hours. Now just imagine, right? A startup, your clients are going to leave you, and your organization is going to shut. So the CTO was scared about that. He wanted to scale to up to 300 servers, but he was fearing that he might need to employ more people just to do deployments. And that is one extreme, right? Now comes to the other extreme where we have Amazon. So Amazon, as professed in 2011, I don't know what is the state right now, they would do a deployment to production every 11.6 seconds. That's staggering, right? 11.6 seconds, something goes live to Amazon.com or Amazon.in or whatever, right? And why is that? Because everything is automated. So they have this system called Apollo in place, by which a developer can push in code, and obviously they have their processes, right? But without manual intervention, it goes right to production. And at a time, you can deploy to 30,000 servers, right? If they want to scale, they can even scale to 60,000, right? So that is what the bottom line is. So as I told you, the gaming company had 40 people involved in development. Here, a single person can basically do the deployment. No manual intervention required. Once a month deployment, right? So the CTO was joking with us that basically on the deployment day, people take an off, so they don't work that day. If he wants to do it every 2 weeks, then people will be taking more leaves that day. So he keeps it at a month. Amazon deployment every 11.6 seconds, right? Even with a good successful deployment, still they had a 2-hour downtime because they had to do all these settings, right? In Amazon, obviously there is no downtime at all. Deployment to only 60 servers. If they want to scale, it's going to be tough. Here the deployment is to 30,000 servers. And the bottom line is, there everything was manual, here everything was automated.
Imagine this was the architecture of the application. And while we are at it, imagine we were tasked with testing the integrity and reliability of this architecture. As you can see, it's a hybrid distributed architecture with millions of machines talking to each other within its own environment through VPNs, let's say, and talking to external systems through internet gateways. Now, the question is, if I want to add a new node or machine into this network, how do I ensure it will work? We definitely don't want to wait till production to find any bug. And believe me when I say that this is a relatively simpler architecture. There are much more complex architectures replicating into gazillions of machines. So let's say I want to add a Mongo host here. How do I ensure that the base image of that node or machine is consistent with others in the network? How do I know Mongo is up and running? And how do I ensure it's running at the same code as expected? That is very important. How does a continuous delivery system like Go or Jenkins integrate like a plug-and-play system in this? How can my testing scripts ensure that? That is very important. Everything should be plug-and-play. And my friend mentioned about scaling to 30,000 servers. It's mind-boggling complex. And automation is the only way to do it. These and similar problems has given rise to the concept of infrastructure as code. The transition is to train ourselves to not just perceive this architecture as a collection of bare metal boxes. They are not, but to treat them as code, just like our application code that we have. And we can very confidently fiddle and experiment with our application code if and only if we have a solid testing framework in place. We can change a line of code. We know that we do unit test, integration test, acceptance test, somewhere it's going to get caught. We will go to Similarly, for infrastructure, we don't want to leave anything to chance. That's the bottom line of infrastructure as code. Next question would be, why to go through all this pain? What is the reason? Why do I do all this? Well, in the current technology business, only the fast, the lean, and the nimble stay ahead in the race. Faster time to market requires rapid iterations. You don't want your competitors to release a feature ahead of you. So faster time to market is most important, which requires increased organizational agility. And in the middle of this growth anarchy, you cannot leave quality at chance. You don't want your users to find their credit card information is getting leaked somewhere. That would be disastrous. So quality cannot be sacrificed. That's where infrastructure as a code is most important. Now, as we know, cost of bugs is least at the time of inception. So we want to make sure when we are provisioning our environment, we make sure that least amount of bugs leak into application. These are some of the technical manifestations of the business concepts we discussed in the previous slide. High confidence in changes and you can immediate feedback. Remember Flipkart's $1 billion sale day when they had a huge marketing campaign and it in some way it bombed because their servers could not take the load. I'm sure that they have learned lessons from that, and the next $1 billion day sale, which I assume is going to come soon, they'll be having some tech test scripts in place to check whether their infrastructure is ready to take the load. Now, in you make one line of change of code, suppose the developer makes single line of change of code. It goes through the entire journey of 90 yards of unit testing, automated integration, regression, acceptance, etc. We want to apply the same standards to our infrastructure testing code, and that is most important when we are provisioning it and when we are maintaining it later. We don't want to depend on any sysadmins for that, as my friend has stressed enough. This is we might identify it as the Brian Merrick's testing quadrant, which is very well known in testing circles of how application code should be tested around whether it's technology facing, support programming, business facing, or UD. We feel, and in our opinion, infrastructure testing also falls in these 4 quadrants. I would keep usability testing a bit side. It might not be very pertinent to infrastructure testing, but apart from this, I think unit testing, performance testing, acceptance testing are very important for infrastructure provisioning as well. The bottom line is not just building thing right, but also building the right thing. Your beautiful app with all animations is useless if your infrastructure is not stable enough to host it. Okay, so lots of talk. Let's get to some action, right? But just before that, feel free to ask any questions if you have right now, so that we don't wait till the end to clear our doubts. Okay, so if you have any questions, just raise your hand. I'll stop and I'll answer. Yes.
So you are mentioning that testing your infrastructure before going live, right? So let's say there is one deployment, and as a part of the deployment, I need to install some package or something, some extra software that goes as a part of my code. Then how should I how should I test that before going live? Until and unless I deploy all my code with that package on the server, I'm not able to come to know that okay, this was fine. And if I'm ready with that, then why should not I release that at that point? So I don't understand how to test this.
Right. So counter questioning in some sense, like okay, say it's an application code in that sense, right? Assume that you don't have acceptance tests. Okay, so what will happen is that you, as you said, you check in some code. Are you going to wait till deployment to actually see that feedback? You're not going to do that, right? So you have some sort of acceptance test over here, which will automate that. Similarly, and in the future slides we'll come to that, infrastructure also can be automated. Up to what level is sort of a question, but there are tools in place which will help you in automating the infrastructure. Basically, what it will do is it will set up an environment on its own. It will help you set up the entire environment on its own automatically and provision your software with that. See, run your what the end user wants actually, and give you that output as soon as you check in any code. So you don't need to do a UAT deployment or deploy to any environment as such before you do that, right? So
it's like creating an image of your actual production is and what
yes,
will be.
yes. So it basically helps you set up your entire environment as is production with all the scripts running, test that entire flow, and then you can come out. Cool. So let's come to the crux of the entire discussion, right? So we understood that, okay, infrastructure as code is good and we need to test our infrastructure. Now, what do we need to test? Let's just run it with a case study. So I'm a client and I'm building a website, and these are some requirements from the infrastructure point of view which I want, right? So he says that the client tells me that, okay, the customer should be able to visit the site and browse the products available. So I have a marketing website, I have some products, and the customer should be able to browse those products. The website should be available 24/7 and should be able to sustain high traffic. Products should not be accessible before the launch date. So some things are secret, which no one should have access to before they actually are launched in the market. We want to launch new features on a regular basis. So the client is agile. In 2 to 3 weeks, he wants to launch new features to beat his competition. He wants to get it out in the market faster. And from an administrative purpose, I just want to know the health of my system, right? That whether my systems are running correctly and issues, if any, should be resolved quickly. So I should have some good logging system which will help me resolve my issues quickly, right? I will need your help for that. So with these requirements in mind, let's come up with an infrastructure, right? What kind of a stack will you have? Let's keep it a bit simple. We are not doing 30,000 servers here, around a small 7 to 8 server stack. So what do you think? What will you need to satisfy the first requirement? Sorry? No, I am talking about infrastructure. In what kind of infrastructure will you need? We are not talking about process.
Configuration of the infrastructure really requires a key stack. So we should have a configuration knowledge.
Okay, sorry. To rephrase my question, I am looking more at developing the architecture of the infrastructure.
Cloud-based?
Right.
It should be cloud-based.
Okay, so assume that it's cloud-based or data center or whatever, but more about the servers and more looking at that. Right. So assume that we'll have a LAMP stack just to start off with, right? A crude LAMP stack. So I'll have a web server, I'll have an app server, right, and a database. So assume that there's Apache and then we have MySQL over here, right? So awesome. This will help me satisfy my first requirement. My client will be up and running. Will be good. Will it satisfy my second requirement? No, right? So yeah. To sustain high traffic, I need some more servers, right? So okay, I'll make 2 web servers. I'll make 2 app servers, and maybe I'll keep my DB itself in a cluster, right? Primary, secondary, and everyone can see this, right? Right. So for this, I will, as you told me, I'll need load balancer over here, right? So balance the load between them. Load balancer over here as well, and this will directly talk to the cluster. This would help me in 2 ways, right? It would help me sustain my high traffic as well as help me to be available 24/7. I can do a blue-green deployment. Well, I take down half of the stack, deploy the code again, bring up the whole stack and deploy the code. And so I'll be available full time. Launch new features, right? So to launch new features, I need something which will automatically deploy and integrate my code. So what will I need over there? Yes. So I will need some sort of a CI setup, right? So assume that, okay, I'll have a Go or a Jenkins tool set up for the CI, right? Which will help me in running all my scripts and stuff like that. And as we have agreed, right? I hope we have agreed that we are doing infrastructure as code. Anyone who has any doubts over that? So we are doing infrastructure as code, and so taking Chef as an example. Chef is nothing, it's just a management tool which helps you run your scripts. So we'll not go into much detail about that. Assume this is a Chef server which holds all my scripts which I want to run on these boxes, right? And finally, for the last requirement, the administrators should, for administrative purposes, I need a logging and monitoring system, right? So maybe for monitoring, I can use something like Ganglia. If people have heard about it, Ganglia, Graphite, whatever, right? And for logging, I would use Splunk, Logstash, whatever, right? So this would help me in actually fulfilling all my requirements, right? Anything I'm missing out over here, if anyone wants to add, will it fulfill all my requirements over here? Yes? Okay, we're good to go. Sorry? Yes, so that, okay, let's come to that a bit later. That is more on the security side. We'll see how we can make our DB secure and keep it secure, right? So we'll come to that, but otherwise it will help me fulfill my all my requirements over here, right? Okay, so Siddharth and I have come up with these 7 domains as such where you need to test your infrastructure, right? Server services, network connections, database setup, deployment strategy, hybrid infrastructure, user management, logging and monitoring setup. What we want you to do is that we'll do a small activity over here. We'll be giving you these the papers, which each one of them will have 1 domain. Arrange yourself into groups of 4 and 5. I think the tables are good enough. And what we want to know from you is that what would you test in each of these domains, right? So assume that you have been given this job. Keeping that infrastructure in mind, what will you test in each of these domains, okay? So we'll give you around 4 to 5 minutes, have a discussion, and then we'll discuss the answers, what you feel. If anyone has any questions around their domain in particular, please feel free to ask. If you are confused about what you need to think about, we'll help you, guide you, and course correct you. So just 1 minute. Please keep this infrastructure in mind. We don't want to go very wide scale, otherwise it will be the blue sky. If you could just keep this infrastructure in mind, it will be easier for us to lead our discussion. Yes. last 1 minute. Let me know if you need more time. Last 1 minute. Does anyone need more time? Last minute, please.
We have a hard stop at 45 minutes stop, so we'll, in the interest of time, let's.
Okay, guys, time's up. First group 1, time's up. Guys at the game, time's up. Okay, cool. So I hope you had a healthy discussion. Sorry for cutting you off. We're short on time. Okay, so who has the servers and services right? So one of you could summarize what you need to test in your infrastructure pertaining to servers and services. So if you could stand up.
So you could test like continuous integration with the code base, and you can check that if the firewalls allow the traffic or not, incoming traffic, and load balancer should be correctly configured.
Right. Thanks a lot. So, in a summary, what you can test basically regarding to your servers and services is that they are running first of all, right? That is the most important and the most basic check. As he said, you need to test that your load balancers are being configured correctly. In our case, we need to check whether Apache has been installed on a web servers. It has been installed on app servers. MySQL has been installed on a database servers. It is running on the right port. All these things are checks, right? If something breaks, then your app, even your application is all ready, that thing will not work, right? We need to check if Apache has the right configuration. So these are basic things which you will check when you're about your servers and services, right? Whether they are running and they are running correctly. Okay, so basically in this discussion talk, we are looking at sort of creating an eye-opener to this domain, the domain of infrastructure testing, right? There are tools and there is automation, but we don't want to go over there. We don't want to tell you all or bias you all with tools, okay? We'll give you a glimpse of what is available over there, and then it's up to your decision. We'll tell you where the framework stands, and who knows, like tomorrow you could come up with your own framework, right? So as Anand said, let's not go behind the tools, so we'll not go much into that part. We'll just focus in totality that how the concept is and what you need to keep your eyes open for. So just giving an example, for unit testing, you have this tool called Chef Spec. Again, all Chef specific. There might be tools for Puppet and Ansible as well. So for unit testing, there's this thing called Chef Spec. Very simple test. What it tests is that, okay, when I run this script, it will do something. For example, when I run the Apache script, it will install Apache, right? This test doesn't check that Apache is running or not. It will just test that, okay, Apache has been installed. Tomorrow, if someone goes and deletes the line of yum install Apache or the package install Apache, this test will fail. Simple test which just checks the script. Then we come to the next test. Now, that is not enough, right? I need to know that, okay, Apache got installed, but is it running? Is it running on the right port? So what I can do is write tests like this. So this actually tests that. This actually tests that Apache, after being installed, is running and is running on the right port, right? So you can write integration tests at this level. Now to answer your question, right? You might be knowing about Cucumber. Cucumber is used given when then format to write your user flows, right? Similarly, for Chef, you have something called Cucumber Chef. What this does is, as I told you, this actually helps you set up your infrastructure and then you can run your given when then, even before writing any application code, right? So you're checking your infrastructure in some sense. As an example, here it says that I have provisioned the following infrastructure. I can give whatever I need. Okay. So I say I have a Ubuntu box with Chef, and the run list is basically what scripts I'm going to run. Once that runs, this is basically what I need, what I can test, right? So I can test that, okay, when I hit this URL, the server is up, everything is working, and it's actually giving me some response back. It is hitting the database, getting a refresh and stuff like that. So this is some sort of a integration test. In my opinion, these form the most important kind of test, because in your infrastructure, you don't have any logic at the unit test level, right? Unit tests are written for logic. Infrastructure is not, there's no logic as such. You're installing something. The integration is what is important. The communication between machines is what is important, right? And that is why the acceptance tests are really useful. Frankly speaking, sadly, the state of this tool is not that great. So the last commit was in 2013. So maybe there are no issues at all in this tool, or people are not using it, right? So there's something wrong over there. There's something wrong over there, which I feel that, okay, there is a scope of development over there. We can come up with something else. So I tried testing a couple of complex scenarios, and it doesn't work. So it can't test your secret files and stuff like that, right? It becomes a bit difficult to write these tests. But yeah, means it does show that the concept itself is good, interesting, and you need to have something like that of that sort. Okay, moving on. Let's come to the next thing, network connections. Who has the network connections? Right. What did you test over here?
So, the main, when the word is network, so first of all, what comes to mind is bandwidth. It's availability. Right. And when you do something kind of deeper than sneaking over the data packet, right. And load balancing, latency. Right. And the most important is like important things are like when something goes in production, then you need a backup. So the one shouldn't affect the other. Right. So yeah, that's possible. This is all why it's a complex system. So we should make a simpler one.
It will not be that bad. Awesome, thank you. So as he said, right, one of the most important parts in testing a network connection is that who is reachable from whom. Okay, your web server should be reachable from the outside world. If that can't be reached, you're gone. Your app server should be reached only from the web server, from nowhere else. No one should be able to hit your app server, right? Your database should be reachable only from your app server. No one else should be able to access your database. And this is what you need to test. Are all your protocols in place? Tomorrow someone goes replaces HTTPS with HTTP. It should not work. It should bomb, right? Something should happen, go wrong over there. Otherwise your authentication and authorization will not work. So those are the tests which you need to take in terms of network connection. Okay, next, database setup.
So as far as the database setup is concerned, we like to test if there is a primary, secondary. If primary goes down, whether secondary will play a role of primary. So for that, we will also test the replication of the database, whether it is happening in sync, should be in sync. Then we will test the load balancing, whether the load balancer is working to route out the traffic. Then we will test the scalability, how much load that database can handle. Then there might be some other scripts which are supposed to be run in order to bring the existing production data aligned with the new feature. So we test if the alter is able to run correctly. And then we'll also see whether we can back up in case of we need to have the restoration for that. Then we will see whether we are able to get the correct backup of it.
Awesome. I don't need to say anything. Right. So as he said, all those things matter. The cluster should be configured correctly. Elections should take place properly. When the primary goes down, someone else should become the primary. When two machines go down, still the environment should be stable and should be working, right? And backup and all those things are what backup scripts, prod dumps, taking prod dumps and stuff like that is what you need to test whether it is happening correctly or not. Okay.
Deployment strategy. Perhaps the most painful but the most important one. Where's that? Yes, please.
So I would like to summarize so the code, so it's based upon the code. So the code goes to correct version of the code. So the folder have correct permission, which should be accessible for the correct version. It should be like accessibility. So we have something with accessibility and the user rights, and then we
performance because check in all the tools. And then branch, where we branch we are checking on
Good points. Some more points I'd like to add. My friend mentioned about blue week deployment. Similarly, there are other kinds like canary release, feature toggles, A/B deployment testing, etc. Most importantly, for deployment strategy testing, there are pre-deployment tests and post-deployment tests to diversify the environment. Pre-deployment tests mainly concern with are the machines up and running, are they ready for deployments? That is fine. Is the database accepting queries, DMLs or EDLs, whatever our DB scripts might have. And most importantly, are our rollback scripts tested well? Because something might go wrong and we want our rollback scripts to be very solid and tested. Many times I have experienced the same. We have some rollback scripts, but we don't test it because who would want to fail something and test? But that is also important. Post-deployment testing or infra smokes, as they are sometimes called, he mentioned good points that we need to test whether the application binaries are of correct versions on the correct boxes. We might not want to install it on all boxes. Some features are rolled out slowly. So that kind of testing. We want to check if artifacts are in correct place or the configuration. In case of multi-local, multi-language environments, we have language packs. Are those properties correctly configured, etc. High availability. Is the server capable of handling the load? That can be tested after the deployment and post-deployment. And something like certificate status, memory status after the app is done, etc. There's a tool by Microsoft called Smoke Tester. It's not maintained as such by them, but for ASP.NET realm of servers, it's quite helpful. Moving on next, hybrid infrastructure.
Yeah, none of our firms are actually using hybrid, or maybe they are not aware of. But what we think gather is basically hybrid infrastructure is a combination of public and private clouds. And what we're going to test is checking how the interaction happens between the private and the public part. See if the firewalls are there and it restricts the private data to go into cloud. We check secret injections. We also check roles if there is certain role assigned for private as well as public. Then I think the public part is slightly easier to test. Maybe the index to be part of it. Obviously, the entire thing comes across both the clouds. And the load balancing part of it because it's public.
I think most of the point which I had in mind, the most important part to test in hybrid infrastructure is the interaction point. It place exactly private and public clouds use. In some cases, private clouds delegate to public clouds when load increases. So that delegation should be secure and deterministic. So that those are some of the highlights. We will move faster. User management. Louder sound. I think, it covers partially the points, but from an infrastructure perspective, I think most important is to test authentication and authorization of access to boxes as opposed to application. That's the idea. So, for example, you can have a script which just tries to access a box with root access. It should fail. That's one of the tests. It should fail. More tests is all the access should be SSH or SFTP, no non-DNS access. Permissions for all kinds of boxes. They should not be accessible to anyone outside, like you mentioned, app to server to DB, etc. So those kind of tests. Last domain, logging and monitoring.
It's part of the logging and monitoring. So consider we are first of all a monitoring system. So monitoring system should have access to all the components. So it should have access to web server. The web server should not have access to the monitoring system. So, and then app server, all the DB and everything. So in that part, we also say that the network connectivity should be there. The ports to read the logs from the monitoring system should be open. So after that, if the monitoring system and the login, and if the login system is the same, and if we are forwarding the logs to the system, so the system, we should keep an eye on the system for the memory, space, and the buffering and the connectivity.
Quite many good points.
And the log rotation and other things.
Coupled to add, are my systems like Splunk and Yahya giving me the right metrics? So if there is a DDoS, am I getting an alert? If there is a bot access, am I getting an alert? Those kind of tests can be scripted by us. And keystroke login on SSH. If someone is trying to access server and there's a spurious activity, keystroke loggers can give me some hints. Those kind of tests. Yeah, I think we are done with the activity.
So these are just some parts, right? For the interest of time, we've come with 7 domains, but there could be many more which you could think of, right? But just keep your eyes open for these kind of things on the same lines. So now let's sort of form a test pyramid. So as you know, this is the ideal test pyramid in the application development world. So large number of unit tests, some integration tests, and some functional tests basically. This is our opinion of what does the infra testing pyramid look like right now. Okay, right now most of it is manual testing, which is good, right? I'm not saying that is bad. Even if you're doing that kind of manual testing, that itself is a big step. But yeah, it is sort of manual. Many things, the frameworks are not good, tools are not good. If people are doing it also, they are doing it by self-written scripts and stuff like that. Going upwards, unit tests and integration tests, the frameworks are good. They are regularly upgraded, and but the developer community is quite active over there. So people, infrastructure developers usually end up writing unit and integration tests. And then the worrying part is that there's some small number of acceptance tests written over there, right? Whatever I can write with that framework, I'll be able to write that, not much. Then I'll have my own scripts, but then I use testing that the connectivity and the communication between the infrastructure. So my question to you is, what do we want it to look like, right? Where do we want to go? What should my future infrastructure testing pyramid look like, right? And I want your opinion for that. Like, where should we concentrate on? What should happen? Anyone?
Basically services.
Okay. So are you saying that there should be more of unit testing?
More of unit testing or service based.
The integration tests in some sense, right? Right. So I feel, in my opinion, the unit tests are not very effective here, right? Because you're not testing logic. You're just testing where packages have been installed. That will not help you much. The actual test should be across, right? Things interacting with each other. And that is where I feel we should be heading. Manual testing is going to remain. Some things will not be able to automate. That is going to remain. But yeah, let's try to move towards the more of the acceptance test, integration test part. And that is what the future is about, right? So to end with, where does this go, right? This domain is very exciting, and trust me, it will boom like anything in a couple of years. Right now, the stage is such that almost around 40% organizations are not even doing infrastructure as code right now, right? And they have to move to that first. But it is a rapid shift in paradigm. If you read Twitter and if you follow some blogs, you'll see that so many companies overnight are calling DevOps organizations to move their infrastructure into code, right? And with that, we need to start testing our infrastructure as well. That is what the future holds right now. As I told you, the automation frameworks are quite amateurish. They are not at a very good level. There is where our opportunity lies, right? Who knows, by next quarter, we might have some of you writing some nice infrastructure automation framework. So who knows, there's a lot of scope over there, and that is what the future holds. And from a skill set point of view, right? For 2 years, I was working as an application developer, and then I moved to the ops world. And when I made that shift, my college days, I remember my college days, right? Whatever you've done in college, the basics, networks and protocols and stuff like that just comes back to you, which somehow you lose in your web development. So for people who are interested in this field, it's a brilliant opportunity to jump onto this, right? I'm not saying leave that part. That is also as important as this. But this is a very good thing to get your basics correct, right? Your basics, your networking basics, your protocol, stuff like that, that it polishes that and makes you really well versed in that. So yes, finally references. So we have referred this really good book called Test-Driven Infrastructure with Chef. More aimed towards the developers, but some chapters are focused on why testing and infrastructure is important. There's a book called Infrastructure as Code by Khalid. It's yet to be released. The early release version is available on O'Reilly. It's a brilliant book where he actually he tells you about why infrastructure as code is important. It's not about testing, but just about getting the infrastructure as code principle out. Okay, thank you very much. Thanks for your time. Thanks for listening to us. Yes, question. Yes, we have time.
You talk about in terms of testing automation, the test automation frameworks are basically the DevOps unit setup, say, or Ansible, or Puppet. Can you do test automation using those skills or direction using?
So Chef is a good tool, right? Most of the testing tools as such are written around Chef only. So as I told you, the unit and integration testing frameworks are like really brilliant. You can do anything with that. But at the acceptance level, it becomes sort of a difficulty, right? For example, hybrid infrastructure, it becomes really difficult to write those tests. Like it will be difficult to spawn up something else in the cloud and spawn it in a data center and stuff like that. The effort is a bit more over there. And that is why what I have seen on projects is that people usually end up testing that manually. But that also is good, right? I'm not saying let's go all gung-ho about automation. Just getting that mindset and having those kind of things will help you in the long run. It will help you immensely. So yeah, I feel, sorry, just to close that. I feel that yeah, Chef and all can be used very well, much more than what it is being used. Yes.
Okay, so I got the point what you're trying to say. I definitely agree with you. But in this, the first or second slide you showed, company A, which took 40 hours to deploy something. Wherever Amazon guy would build it in 1 second. What I think is you are not comparing oranges with oranges. At the back end, Amazon must have spent years to get this thing working. Okay, so my question is, so maintaining this kind of infrastructure to get everything deployed on a hybrid cloud is a difficult task. You have to spend time and energy on it so that it gets completed in advance. So my question, when to actually do this and when not to do this?
Right. So as you said, right, the point was just showing two extremes, right? We are not trying to, the gaming company obviously if it wants to become Amazon, it will take some time, right? But had they started off with that itself, their deployments would be much lesser, right? They could easily scale. They would not need to call in third-party vendors to actually help out with those solutions, right? And they would have spent just less resources. If you just see in the terms of numbers, if you check in terms of money, they would have spent less resources. Where you would not do your, I feel infrastructure, even for 5 servers, infrastructure as code is necessary, right? I've had pain where 5 servers, if I've done things manually right, when I need to add the 6th server, I'm all lost about what has happened with those 5 servers. And infrastructure as code comes in at any cost. If you just have 2 or 3 servers, that is okay, right? That will not matter. But anything of a suitable scale, like something like this, where you will have 6 to 7 servers, there you need to have your infrastructure as code. It will just help you making things faster, right? Things break will come to know easily. And manually it becomes a hell lot difficult. Like the cloud, especially if you use Amazon or something, trust me, they have so many firewalls and like they have networking, subnets and VPCs and stuff like that, that if you do anything manually, right, one change and the entire system will go for a toss. You will not come to know that what changed. But if you have your infrastructure as code, you can just reapply that template, everything will come back to normal. And we have seen that like it helps you tremendously. So I would say that whatever the scale, you need to do that. The earlier you start, the better. That will help you scale. You will not have the fear of scaling. Yeah, does that answer
we at the time of the post deployment only we set up everything.
Yes. So essentially, when you're as an organization, right, you might feel that no man, I need to get out to market fast. In the 2 weeks, I need to develop this. Just do it fast and just get it done, right? And that cycle continues. But even the first step, you say that okay, my first release will take some time, but I'm going to get everything in place. Then you just see that how your eventual releases happen, right? So right now, after 3 years, they are facing this problem. Had they not done it, they would not have faced the problem. They could have, in the first year itself, scaled to 300 servers, right? But they're not able to do it even after 3 years. So that is the worrying part. You need to start from the start itself.
Even if it runs server, it's a repeated task.
Yes. Yes. So why make it consistent, right? We don't want any snowflake server where someone touches that server and it's gone. We don't know what happened. So if the infrastructure is code, we know everything what is there on that machine. Sorry.
I just take this as opportunity to break us here because you want to start a lunch on time. I know it's triggered a lot of questions. They both are here for the entire day. Nag them as much as you can. And I would like to give them a token of appreciation here for doing such a brilliant talk. Thank you, Yahya.
Thank you very much. It was really an interesting crowd, and it was